Although the study of motion was first started with Aristotle and Archimedes, but Galileo was the first to define the motion of a body in terms of position and time. And his experiment was the first ever documented experiment in physics that is related to motion. Experiment of a freely falling body from Leaning Tower of Pisa. But during his experiment, Galileo has faced two difficulties. One is air resistance to the falling body, and the second one is to measure the small interval of time that is required by a falling body to reach the ground, because at those days there was no exact timepieces. So he solved these two problems quite ingeniously. Here in this video we can see how he has done it. He has taken an inclined plane or wooden ramp at very shallow angle so that the air resistance is minimized and time required by the smooth ball to roll down the plane is maximized. Now the problem was to measure the time, because as we know there was no watches at that time, and Galileo solved it by using the properties of flowing water. He actually rolls down the ball from different location of ramp and collect water at different container for the time required by the ball to roll down that length. And when he took weight of that water stored in different containers, he found an exact pattern of decreasing weight. It is due to the fact that as the ball rolls down, it took lesser time to cover the same distance. Hence Galileo concluded the time required by the ball is lesser and lesser as it goes more and more. Hence the ball is speeding up. He finds the ball is taking same time to roll down the first 1/3 length and remaining 2/3 length of ramp. So depending upon his observation, he fixed 4 bells at different location of ramp. Here we can see the gap between the first 2 bells is much smaller than the gap between the last 2 bells. And principle is that the time required by the ball to roll down the first 1/3 length is same as the remaining 2/3 length, and we will hear the bell at equal interval of time. So in this way, Galileo was able to recognize a pattern that any freely falling body will cover a distance of 1 meter in first second, 4 meter in second second, 9 meter in third second, 16 meter in fourth second, and so on. So based on his observation, he proposed a relation between distance covered by a freely falling body, that is d, and time t, which is d is proportional to t square. Later we will find, that is, we can write it as d is proportional to t square, and we will find that this is an equation of uniformly accelerated motion. So after this mathematical formula stated by Galileo, Newton was first who stated that a force is responsible for this motion and gives us a way to define it both qualitatively and quantitative manner. This initiates a different branch in physics known as mechanics. However, Newton modified this law in the context of, that means this law of finding the force in the context of energy formulation and strength of materials and plasticity. After there is Einstein, he stated Newton's law is not applicable in every situation, like when the body is traveling with the speed of light, and declares a completely new branch in mechanics known as relativistic mechanics, and the phenomenon responsible for it is known as relativity. Also, we will find there is another situation in the realm of, that is, in the realm of subatomic particle, where we cannot apply Newton's laws of mechanics. Actually, these are the basic law on which nature depends, and it replicates in higher scale to produce Newton's law. This branch is known as quantum mechanics. Hence, we can identify mechanics, that is mechanics to be a branch of physics that deals with motion of a particle or body and related formula, that is math.